cloud-native analytics and observability, right? Guys, so this is the plan for the day. First off, before going into the main topic, just to build some context and also put things into the perspective. So I would like to build up, I will give you some information about the platform that we are building and what actually cloud native means and what observed means. And then I will go on to explain how we have used these observability technologies to build in a comprehensive observability platform for our API management platform. So that is the plan for the day at a high level. Right. And also after all this, so it will be followed by a Q&A session. In case you have any questions, please do ask at the Q&A session. I'll be happy to answer. Yeah. Okay. Before, as I explained before, going into the details of observability, for you to understand about the context and build some understanding about the system, I think that will be really helpful for you to understand how we have architected our observability solution to build on top of this API manager, Axonect API manager. So you might be wondering, okay, so what is Axonect? So Axonect is actually a brand that is launched recently by Asiata Digital Labs. So it aims to deliver a comprehensive range of products that enables rapid digital transformation for businesses. So that is Axonect. So in case you're wondering what Axonect is. So Axonect API. So this observability solution, this observability implementation that I'm going to cover today is specifically built for Axonect API management platform. So let me give a very brief introduction to Axonect API management platform. So it's a fully fledged API management platform. So when I say fully fledged, it doesn't just cover the core basic API management capabilities. It covers other aspects such as identity and access management, and also traffic management, observability, and that is what we are going to discuss today, and other aspects that is covering API management, so that it is a comprehensive package, so which contains all the aspects of API management. And also we embrace open source software. So of course, I mean, all the software that we have used, external software that we have used to build our system, are open source software. So as we are going to see, even to build this observability solution, we have used all open source software as well, right? So, and also we being a telco, of course, we do have pre-built integrations for telco specific services as well, both for operators and for both and for the business side. And also this will help the customers who are going to willing to deploy our system to go to market in a comparatively less time. And also another one of the key features that also demands us to, build observability platform, observability solution into this platform is that it's highly scalable and pluggable nature. So the reason for its being highly scalable and pluggable is that we almost all the deployments that we have currently running are handling a large volume of data. Right, so it's handling, and so in order for it to be able to handle that large volume of data, it is most of the time it is deployed as a distributed system. Distributed systems mean there are many multiple replicas of the same component, and also there are many different types of components which are working with each other. Right, so the moment that you move from a small scale like 2-3 server system to a multi-node server system where you have several dozens of servers. So the complexity, grows up rapidly, exponentially, right? So yeah, so this is it's a very brief introduction to the Axonect API management platform. Right. So, and also to zoom in a little more, just to give you an idea about what components are there. So mainly, like if you think about the control plane, where the users come in and interact with the system, do their configurations and do the designs of APIs, publishing, and all these interactions are done by the control plane. So in the control plane, there are mainly two portals. So one is for designing and developing APIs. And the other one is for the application developers who are the consumers of the API. So I'm not going into details of that because it doesn't like necessarily fall in this scope. And also the most important part that is concerned in this session is the data plane, right? So data plane is where actual API is where the components which are handling actual API request or the user requests are residing. For an example, the API gateway. So API gateway is the component which intercepts user request and apply all these API management policies and then pass it down to the underlying services, right? So that is data plane. So this is where actually observability is crucial, right? And also, as I explained earlier, we have identity and access management integration, traffic management integration, and analytics and insights via observability, right? Right. Okay, so that's some that's I hope now you have some idea about what about the system that we are that the system that we are going to talk about, which the system on top of which the observability the solution is built on, right? So I think that is important for you to get at least a basic understanding about the core system, so that you can relate things more better when we are talking about the observability aspect of it. Right. So now then, cloud native, right? So I know this term is like heavily used, and it's a heavily used buzzword, uh, right? So I mean, it's been there for like around, let's say, 5 years or so, right? So so if we try to define, or if we try to understand what cloud native means, so according to Cloud Native Computing Foundation, right? So they say cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. So this is the definition sort of the Cloud Native Computing Foundation have given. So if you are not aware of what Cloud Native Computing Foundation is, I encourage you to go and check out their website. So they are sort of like, bringing in all these cloud native technologies into a single federation, and then sort of, I wouldn't say they govern, rather like try to consolidate the efforts that are happening at different places into a single focused effort to build a proper and industry ready cloud native software. So they have so please go ahead and check that. So however, so this basically means that if your application is cloud native, it should be able to run on a cloud environment very easily, right? So it doesn't we have to understand that not every application is a cloud native application. So for it to be able to run on a cloud environment easily, there are certain technical characteristics as your application must hold. For an example, it should have a lower resource footprint, right? And it has to be disposable. And whenever possible, it's better if it is stateless, right? So likewise, there are there are quite a few characteristics that your application should hold if it's truly to be called cloud native. It's not that you can't run any JVM or a process within Kubernetes, but of course you will find it hard to scale, to implement fault tolerance, and and maybe run as a container. So it will be really difficult, right? So therefore, cloud nativeness means, so okay, in simple words, you can run your application very easily on cloud environment, right, and a containerized environment. Right. So that is cloud native, right? So now we have built the context. Okay, we talked about the system, and okay, we talked about what cloud native is. And of course, if we think about the two things together, so we have implemented our system in a cloud native manner, meaning that it can be deployed and run on a cloud environment easily, right? Okay, so that's okay. And then what is observability? Right. So is it the same as monitoring? Is it just some dashboards, right? Or is it is it a so what exactly is observability? So like before we try to define what observability is, like mainly there are three pillars of observability, or like these are the three ways from the main three means that provides that enables observability. I could say like that. Like so, there's are metrics, traces, and logs, right? So what are metrics? Metrics are simply some numbers. Like if you put it in a very simple way, it's just some numbers indicating a certain aspect of the system, right? For an example, request counts, how many requests have been received, right? And then comes traces, right? So traces actually allows you to track what happened to a certain process when it's executed inside your system. For an example, if a user request is being received by your system, what has happened as it goes through or as it travels through the system, right? And then logs. Logs is essentially, we all know, okay, any important information, errors, and any, let's say, any non-error, even if it's not an error, if it's an important event in the system, we print logs, right? So logs. So these are the main three ways that allows us to, have an insight of the system, right? Have an insight of the system, right? So observability is actually using these three means, right? That are matrices, traces, and logs to gain a real-time view of the system state. So in general, what we are trying to do is we are trying to get to the real-time view on what? On the system state. So real time, it's being real time is also important, right? So real time means it allows you to know, okay, what exactly is happening right now, right? Of course, it is important to know what has happened in the past. That is what we mostly do when we are doing troubleshooting. We try to do postmortem. We try to go and see back, okay, what has happened to that request. So of course, that is important. I'm not telling that important, but real time views is also equally important, right? So with real time views, actually it enables you to take proactive actions. For an example, let's say if you are consistently seeing increase of your CPU or memory, right? So of course it can your system might elastically scale up to a certain limit, right? If you have enough allocation, but you might need to go and see why exactly it is taking this much of CPU. Is it a DDoS attack, or is it a problem in your application? Right. So without waiting until the system crashes, you can actually proactively go and investigate that, so that you make sure that your system is in good health all the time, right? So you gain a real-time view at the system state, right? So with all these, I mean, actually matrices, traces, and logs are actually like, windows that allows you to, see through to the system and let you get insights, right? So what you are really looking at is the system state, right? So system state might, it will give you information about the performance, right? And also it will allow you to, troubleshoot errors. Of course, that is more of a reactive thing. And then identify bottlenecks, right? Sometimes your system might not be performing in the way that you have designed it to perform, right? So in such case, how can you possibly identify that, right? If you don't have a proper observability system in place, of course, it will be a very, how do I say, it's a tedious task. I mean, you might have to invest a lot of time and, so that's the need of observability. So observability is essentially letting you see through the system in real time through metrics, traces, and logs, right? Right. So now that is observability. So observability is of course important for any system, but it is more. I mean, we can say it's even more relevant in the context of cloud native applications, right? Cloud native applications. So there are a few reasons. So one is being when we develop cloud native applications, right? So when we develop cloud native applications, we almost all of the time we adopt this microservices architecture, right? So unless if your binaries are heavy, it's hard to run as containers, right? And resource allocation is a lot, right? Uh, Likewise, there are various complexities that brings in. So almost all of the time we adopt the microservices architecture. So what does microservices architecture mean? So microservices architecture means we are decomposing the overall system functionality into smaller parts, right? So smaller parts. So these smaller parts are implementing a cohesive function, right? And these multiple parts will interact with each other to provide the whole functionality, right? So the whole functionality is provided through multiple integrated or interacting set of services or components, right? So because of this fact, now you can understand now the system state is scattered, right? The system state is scattered. So only one process only knows part of the story, right? It only knows, okay, what happened to request while doing, let's say stage 1. Okay, then if it's all right, if it's all good, it will pass it down to stage 2, which might be handled by another microservice, right? So the first microservice will not have any knowledge on what will happen at or what has happened on the on stage 2, right? So therefore now we can see now this state is scattered, right? Right? So therefore, we have to have a way of integrating this data together and building a consolidated view of the system. Regardless of the fact that it is physically distributed, we have to have a consolidated view, right? And also, when we talk about the cloud native infrastructure, guys, I mean, we know I mean, yes, cloud native development is cost effective, and also it allows agile development, and also it's very easy to manage. And there are so many advantages, but of course, we have to admit that there's a certain level of complexity this cloud application brings us in, right? Because of the fact that there are multiple layers. For an example, there is a provisioning layer to provision the resources, maybe elastically for you to start up with likewise. And then the application layer on the layer that actually executes your code, right? And then comes the runtime, right? Docker runtime. So that runtime layer is there, right? So that's your application might be embedded inside that runtime. And then the infrastructure layer, right? So infrastructure layer, you might be running it on GCP or AWS or wherever. So now you can see it's quite how do I say? It's quite complex, and it has more moving parts with compared to a system where you actually deploy your binaries on, let's say, bare metal and execute it. So of course it has its own set of well-known problems, but what I'm saying is in terms of the layout, right? So therefore, we need to be able to see through these layers as well, right? So it's not just what application does, right? In order for you to get a comprehensive view of the system, you need to be able to see through this infrastructure layer and the runtime, what happens at the application layer and what is happening at the provisioning layer, right? So you get the idea, right? So we have to, therefore, there has to be a proper system which allows you to see through these layers as well, right? So unless what can really happen is like, because there are so many moving parts, right? There are so many moving parts, things can go, out of hand very easily if there is no well-defined systematic way of observing your system. So that's where the need of observability comes in. I mean, where you feel the need of observability more in cloud native space, right? So when you have a proper observability system established, you can very easily know, okay, what is the current state or health of my system, right? And also what has happened to each of my requests, right? So I will go into the details as to how we have implemented this. And also, okay, let's say there's a production incident and the customer claims, okay, my request is not being processed properly. So how can I actually go and investigate that? And when you are investigating that, you can't leisurely take any amount of time that, right? There's a certain SLA that you have to, fulfill. So all these things has to be facilitated through this observability system, right? So if so I'm trying to convince that, okay, if there's no proper observability system in place, this can be a nightmare, right? Okay, right. So now, yeah. So now, as I explained before, like we ourselves, felt this because we being, I mean, running these systems for for a long time now, nearly a decade. right? So we have learned our lessons through practical experience, right? So as I explained before, like, so I have just dumped a system high level. This is actually a high level system diagram. This is not even deployment diagram. So, right. So this is, I mean, in most of our customers and on most of our people who use it, this is how this is deployed. It's, you know, there are multiple parts that are talking with each other and working with each other in order to, you know, keep the system running, right? So therefore, we have to have a proper way to observe our system, right? For an example, okay, we have to have a way to find out, okay, what happened to each request at each stage, right? Because it goes through multiple stages, right? It's not just what happened to, you know, it has to be a granular. We have to be able to get a granular view about the state of a request at each stage, right? And then what is the overall system health and performance, and how each individual components are doing, right? So we might see okay, the overall system the overall CPU usage has gone up, but okay, now there are 10 components that are there. So who really causes that, right? So likewise, so you need to be able to drill down, right? So that drilling down capability has to be there. And also, what are the causes of, you know, system? There can be errors at system level, maybe at the application level, or probably there might be business errors. For an example, a business validation might have failed, right? So for that very reason, a request might have been rejected, right? So therefore, but still you need to be able to find out, okay, what really caused that, right? So all these, it is important for us to know this information in order to keep these systems running in the real world, and you know, and cater to real customer requirements, right? And also not just customer requirements, and also for operations, and keep the system running smoothly, right? So that is, so okay, in order to cater to these requirements, right, we ourselves actually implemented an observability system. So in that observability system, we tried to cover, we tried to implement the system by using all the three pillars that I mentioned before, that is metrics, traces, and logs for the Axonect API management, right? So that's okay. So yeah. So now what I'm going to do is I'll try to explain each of the how we actually implemented our. I mean this is, of course, I don't intend to go into very technical details. Rather, what I'm trying to do is introduce you to the technologies that we have used, and also give you guys a very high level idea as to how we have laid out, or how we have integrated these technologies together in order to, you know, fulfill these requirements that I just explained. Okay. First, operational metrics or metrics, right? So as I explained before, so metrics are simply, you know, it's just numbers, right? So so these numbers indicates various events that are happening inside the system. For an example, how many requests have received. So what is the processing latency, right? Likewise. So these are the metrics. So when we talk about metrics, guys, so the one good thing, the one important factor about metrics is metrics can provide you very focused view or granular views at, you know, at very specific aspects of the system. For an example, how many requests have been received by a given gateway instance, right? So it can go into that level, right? If you use labels and all, I mean, you can go drill down into even granular levels. And also, it allows you to aggregate all these in all these matrices, and also generate a holistic picture about the whole system. So that is also possible, right? So that's, I mean, so it gives you very specific information, as well as a summary of, I mean, for an example, how your overall system is doing, how your gateway cluster is doing, right? In contra, right? So that's very that's a very useful feature of metrics, right? So in order to implement metrics, we used Prometheus, Cortex, and Grafana, right? So we all know the Prometheus is actually So, I mean, I'm sure most of you guys have heard about Prometheus. So it's actually a time series database, right? And also it allows you to label data into multiple dimensions, right? So it's a time series database, allows you to label data into multiple dimensions. So it actually allows the Prometheus agent and the Prometheus how do I say, the Prometheus server allows you to collect these matrices and store them and basically collect matrices, right? So and then you might be wondering what Cortex is doing here, right? So almost all of the time when we talk about it, we always say Prometheus and Grafana, right? So that is the stack. Those are the two technologies that go hand in hand, right? But one of the key, rather than, I mean, it's not a problem, but by design, Prometheus is it is not scalable, right? So it just intend to be a self-sufficient small server where you can, use to do this metrics type of operations, but I mean, because it's not scalable, right? It's not scalable, and it doesn't support other concepts such as multi-tenancy, right? So it uses a local storage. So therefore, I mean, because we are talking about systems that are handling millions of requests, so we need that scalability. So in order to provide that scalability, we used Cortex, right? So Cortex is actually, I mean, it's built on top of Prometheus, right? So, but what the beauty of Cortex is it provides scalability. You can plug Cortex with the cloud storage, and data retention can be, I mean, virtually it's limitless, right? And also its architecture allows you to scale it horizontally, right? So likewise, that's the main usage of Cortex, right? And then Grafana, we all know Grafana is for visualizing. And one thing I forgot to tell about is actually we use Prometheus and Cortex for alerting as well, not just collecting metrics, but and processing metrics and storing in them time series data, but also for alerting, right? And Grafana is used for visualization. So this is a very high level view of how this is being implemented, right? So there are, I mean, mainly if we talk about metrics collection, right? So when we are implementing an observability system, one thing is like identifying the correct sampling or instrumentation or metric collection points, right? So here we mainly focused to being able to observe the request processing path, right? So this, as I said before, this is a API management solution. So as an API management solution, what we'll be mainly doing is like we will be getting API requests from the outside world, and that request will be go through the API gateway. The API gateway is the component which applies all these API management policies. So once that is done, that request will be passed down to the service calls, right? Service calls. And so these services might again go and talk to other services. And then, of course, the response will also go back through the same path, right? So you get that, right? So you get a request and an external request, API gateway will process it, and then it will trigger a service call, right? And this might also go and call back some other services, and then the response will also flow through the same path, right? So we try to observe this path, right? So therefore, in order to collect useful numbers about this operation or this request flow, we collect matrices at API gateway and the microservices, right? So how do we collect these matrices? We use Prometheus agent, right? So it's basically we are burning in some code to collect these matrices. So if you are familiar with the Prometheus API, so it's quite simple, right? So it has set of matrices like histograms and timers and latches. So it's a unit you need to increase and decrease. The API is quite simple, so I'm not going to into details of that. But the idea is that there's a Prometheus. We use this Prometheus agent to collect information at the API gateway and the the services, and these basically these matrices are falling in two broad categories, that is counts and latencies. When we say count, like request counts, error counts, DB call counts, right? Number of bytes that is written likewise, and then also latencies like processing latency, DB call latency, backend travel latency. So right, so likewise there are many other latencies that we try to track, right? And then, so one of the key characteristics of Prometheus is like this agent actually doesn't push data to Prometheus, right? Push data to Prometheus. Rather, what it will do is it will scrape data from. I mean, these agents will expose themselves, right? And then expose the metrics. The Prometheus server will go and scrape them, right? Scrape or pull them. So it's a pull model, not a push model, right? So now, as I explained before, this Prometheus is actually not horizontally scalable multi-tenant software tool. So therefore, we had to look for a solution for that to provide this horizontal scalability on top of Prometheus. The Cortex is the answer. So what really happens is the Prometheus actually write the data. It's a remote write. It has a remote write API. Remote write the data to Cortex, right? So Cortex will actually store this data in a cloud storage, and then integrate with Grafana. So Cortex has a component called query handler. So that will actually handle Grafana requests and then provide required data to Grafana to visualize, right? So that's the basic. That's how we have put these technologies together in order to get the required insights in terms of metrics. So this is a deployment view of that. So we run all these in Kubernetes most of the time, right? So we have application namespace, and we have our application pods running there, and the Prometheus server. So it will pull data from the applications, and then we have the Cortex server, right? So Cortex, so this is the deployment. So we have a service in order to enable accessing the Cortex server, right? And also for the query service that is used for Grafana, right? So these are two Kubernetes services, right? And then finally, it's been exposed outside through ingress, and then to expose this to outside world, right? So we use an Nginx ingress controller, and this is the contact point for the external world, right? So it's a very, I mean, this is of course a simplified view of our deployment. So how we have designed the deployment on Kubernetes, right? Right. I'll show a very brief demo of what we have done as well. Right. So now this is the Prometheus server side, right? So now what this essentially shows is, so from the gate, so what are the endpoints that is exposed by the AXP platform for scraping? So I explained before that Prometheus server will scrape data from the servers or the processors. So this basically lists, okay, what are the endpoints that are out there to be scraped. So it says, okay, it was last scraped 1.252 seconds ago. Like it gives some information, right? And okay, and also one thing to note is, guys, so because because these most of these are CNCF projects, they support close integrations with each other, right? So if you take Kubernetes, it's also a CNCF project, right? So it uses Prometheus to actually expose its metrics, right? So if you look at these metrics that is being exposed under these labels via this endpoint with these labels. So these are basically, I mean, we didn't have to write any code to get this information out. We only had to, enable these configurations, but once we do that, these information are automatically exposed by Kubernetes, right? So that's the beauty of it. So we get a lot of insights about the provisioning layer and the infrastructure layer without, with very less effort, right? So that's the beauty of this ecosystem, this cloud native ecosystem, right? So these are the endpoints. So if I go and show you some, so these of course, these endpoints are exposed by Kubernetes, and of course these are exposed by the application, that is the gateway that I was just explaining. And then if I go and show the metrics, so we have a few dashboards. So this dashboard is actually, it gives you, details about how each pod is performing, right? So if you are specifically, let's say if you want to just check the gateway, right? Okay. I mean, there are many pods. I mean, you can choose anything, but I just wanted to show you application. Yeah, I think that maybe that is down now. Yeah, so yeah, that let's select one of those. Yeah, so this is a metric server, right? So you can just drill down. So you don't have to. I mean, it's just a little noisy before. Now you can just drill down. So all these are coming from Grafana. We don't have to do anything, right? So it's just that it's that easy now. Now see, like, you get a very good insight as to what is the CPU usage and what is the memory usage, how it has been interacting with the network, right? So that all that information is being nicely visualized, and also lets you that in turn enables you to troubleshoot and also have a very good understanding about the current system health. So there are a few other dashboards as well. And this is for the Nginx ingress controller, right? So now we can see, okay, what is the latency? 50% percentile of latency. It's 20 millisecond, 90% latent percentile is 23. Likewise, so it gives you a lot of useful information, right? What is the TTL and what is the average memory use? So this is at the ingress level. So for an example, let's say your system is there's a DDoS attack, right, on your system. So that means that is coming through your ingress, right? So ingress is where the external traffic flow in and out, right? So you should be able to see, very easily identify that, right? So, right, or for an example, it might not be an attack. It might be the case that one of your users are suddenly sending large payloads or fetching a lot of data, right? So these you can at the very at the very edge of the system, you can identify that, right? So likewise, and then yeah, so we have a node level overview. So this is a Kubernetes cluster. So let me sorry, okay, these are, okay, we are using 4 nodes in this system, sorry. So how the nodes are doing, right? So now we can say this is the infrastructure level, right? So how each nodes are doing. So what we looked at before is at more of the Kubernetes or provisioning level, right? And the application level. So how the infrastructure is doing, what is the memory usage and what is the CPU usage, etc., right? Right. So of course we are still working our way to build more comprehensive application matrices. So that work is still in progress. Yeah, and this is the pod overview. What happens for different pods, right? For you can get pods for just one node. Likewise, so there are many options and then many drilling down options that is there. Right. So the idea is what I'm trying to convey is that, okay, we are trying to build a set of layout our metrics in a way such that it gives you an idea about all layers of the system, as well as if you detect a problem at some point, it will let you drill down and find your way all the way down to the root cause. So that's the main aim of that's the main one of the main targets of this system design, right? So that is metrics. And also we are using Jagger and OpenTelemetry for distributed tracing. So tracing is a little different. It serves a different purpose, right? So with metrics, it gives you numbers and counters about what has happened and indicators about what has happened. And also you can have system scoped numbers with metrics. But distributed tracing is more focused on letting you know what has happened to each request, right? What has happened to each request. So here we are using Jagger and OpenTelemetry. So the OpenTelemetry is actually a set of things. It's not just one thing. It's a set of APIs, tools, and SDKs that allows you to actually, as they refer to them, collect this telemetry data. So telemetry data is, of course, the same three pillars that I just explained. So it allows you to collect this telemetry data, right? So it allows you to instrument and collect metrics, generate metrics, and all that, right? But in our use case, we mainly use it for publishing traces. So we don't use it for matrices and logs. So we use it for tracing, right? So OpenTelemetry, right? So this is a very high level overview of that. Of what's being implemented. So again, we use the OpenTelemetry agent to generate traces for the API gateway and for the services, right? So we use OpenTelemetry to do that. So it will publish traces to a component called OpenTelemetry or OpenTelemetry collector, right? So so why we are using OpenTelemetry here is that this is actually vendor neutral, right? So this tracing, this is standard API, right? And then this tracing information is being passed to Jagger, so which is actually the distributed tracing visualizer and the collector, right? So that is actually builds in the semantics of distributed tracing, right? By looking at these traces, it gives you a visualization as to how distributed tracing has happened, how the request has flown through different components as the process happens, right? And also, in order to store this information, we use Elasticsearch as the DB, right? Right. So yeah. So this is again the deployment level view, right? So we have the application and also we have the tracing namespace where you have the OpenTelemetry service collector, and then we pass it down to Jagger service collector. You might, as I explained before, you might be wondering why we have this in middle. So this is to make it vendor neutral and use a standard API instead of being married or binded or bound to a specific software tool, right? And then we pass it down to Elasticsearch, right? So Elasticsearch is then storing this data through a PV, right? And then the Jagger has a nice UI, so I'll show it in a little while. So this UI will be exposed to the outer side world via our ingress, right? So let me. So this is the Jagger UI. So this is one of these traces, right? So this is so we are actually in the process of bringing in the process related traces into this trace as well, but this just shows what has happened inside our API, right? API gateway, right? So it has gone through multiple validations and multiple handlers, and then it is being dispatched to the backend, right? And then it has spent 3.49 milliseconds there, right? So likewise, it gives a very detailed view as to what has happened. So of course, with more instrumentation, you can add more information into this, okay, right? So like you can add logs and you can add more information. So, but this is very, yeah, but also it's important to know that it's not good to, in instrumentation to be very heavy. Yeah, so you can see like as the process is being, request is being processed, what I mean, what are the stages that it has gone through and how much time each stage has taken, right? So this is very useful, right? So let's say if your backend is very slow, you will see, you might see at a high level, at the external, as an external user, you might say, okay, it takes 5 seconds for my request to give me a response. Well, right? But if you want to troubleshoot it, this view is very useful, right? At a single glance, you can say, okay, this is what it causes. This is the cause of it, right? I mean, this is where the most of the time is being spent, and then you have to move into logs or metrics to see, okay, what might be actually causing this, right? So this will give you the first insight and the entry point to find the problem, right? So this is the Jagger, right? And yeah, because the time, yeah, I think time is running out. I'll quickly go through the log analytics part as well. So log analytics, of course, is one of the most important things and one of most traditional ways of monitoring systems, because I mean we all know logs are like very important. I mean, it has to be a part of your development process, and it has an effect on the performance of your system, how you handle exceptions, how you write code, and it's a. Actually, in my personal view, logs is actually, I mean, it's something that you have to give more consideration, and from the time of the first developments of your application. So down the line, when you run this in production, your life will be very easy if you have put that thought at the inception, right? Okay, so here, so logs, as we all know, it continuously emits or it continuously dumps important information into a file, into a persistent file, right? So this information can provide you real-time insights, as well as, because these logs are most of the time are archived and kept safely until some time, you can use this to troubleshoot, right? If some problem has occurred, if someone is complaining, okay, there's this problem, right? So you can go and take a look and see, okay, what has happened, right? Right. So for this, the technology stack we are using is actually, we are using Nifi. Nifi has an agent called Minifi, right? And Elasticsearch for index processing and log, and Kibana for visualization, right? So if I tell brief, I'm sure you have heard about Kibana and Elasticsearch, but Nifi might be new for you. Well, actually, it's a stream processing or data processing framework, which allows you to handle data as a stream or generate a stream and then process that stream, right? Stream of data. So so that it's a general purpose tool to handle streaming data, but we are using it for the purpose of streaming logs and processing that logs as a stream of data, right? So that's the usage of Nifi and Minifi. Minifi is actually the agent, right? So as I explained before, so the gateway and the API services are generating logs. This Minifi will sitting closer to them, right? Sitting closer to them, and then as and when the logs are printed, it will stream that log, right? As if it's been published as events, right? So it will stream that log to Nifi. This log extracts are sent to Nifi by Minifi, right? So that's the agent, collection agent, right? And the Nifi will actually process this data. So you can define various logics at Nifi to process this data. Okay, convert it to a JSON, filter this out, filter that out, multiply, and do various types of processing like you do with SQL. But of course, it's a visual tool. I'll quickly show you that as well. And then these process logs are sent to Elasticsearch, right? Elasticsearch database where they are indexed and stored. And then we are still in the process of developing these UIs, but the Kibana will be used to visualize this data, right? So this is the basic flow. So this is a deployment view of that, right? So we have the application and we have the Minifi, which is sitting closer to the application or sitting next to application. And then we have Nifi server, right? And then we have the ELK stack, right? So, okay. And then I'll quickly show the. So this is the Nifi flow editor. Sorry, I'm not sure why. Is that? Okay. So this is the NIFI flow editor. So I am not going into details with the limited time. So this is, I mean, here you can configure, okay, Minify to so yeah, you can simply configure the Minify agent to collect data from logs extracts from various locations, right? So you say, okay, collect this from this location and collect it from this location likewise. And then this data can be pumped to, different processing elements. So these processing elements will process that raw log extracts into different forms, right? So that is being used to, visualize or generate alerts or even generate business insights. So that is one part that I didn't cover here because it doesn't fall under observability. So we also use the same flow to generate business insights via Power BI as well. So that is not actually covered in this. So, but so this is, I mean, this using this flow editor. The idea is that you can, configure it to, the Minify to collect this data from various log locations and then stream them and then process them and then maybe dump them down to DBs or dump them down to different. Here we are put. This is the flow that actually publish data to Elasticsearch. So in here we are simply converting the log entry to JSON and then dumping it to Elasticsearch, right? So, but there are many other things that we are doing with this as well. So this is now available in Elastic, and these are the indices. So we are yet to build the visualizations for using these index and data. Right. So yeah, so that's all I wanted to cover for the day. Yeah, we are almost at the time. So yeah, if you have any questions, like I would be happy to answer.
Thank you, Sajith, for this insightful session on such an interesting topic. Does anyone have any questions or clarifications about the session topic or any other areas that needs to be explained? If you have any questions, you can type it in the comments or raise your hand. All right, Sajid, the audience seems to be clear on your topic of the real-time cloud-native observability. Thank you once again for taking your time to conduct this knowledgeable session, and thank you everyone for joining. Hope to see you everyone again at the third session at this later this month. Thank you.
Thank you, everyone.